In the vast emptiness between the stars, there are travelers, icy remnants of long-forgotten worlds, wandering endlessly through the dark. Most never come close to any sun, but once in a great while, one passes through our solar system, a fleeting messenger from the space between stars. In early 2020, astronomers detected one such visitor, Comet 3I/Atlas. It was only the third known object confirmed to have come from beyond our solar system, following Oumuamua and Borisov. For months, it streaked across the heavens, a faint, greenish ghost unraveling as it approached the sun. And then, something unexpected happened. For the first time in history, scientists detected radio signals coming from an interstellar comet. It wasn't noise. It wasn't random. It was a whisper from another star, and it changed the way we look at interstellar visitors forever. When 3I/Atlas was first spotted, astronomers noticed something unusual. Its trajectory was hyperbolic, a path too fast to be bound by the sun's gravity. That meant it didn't originate here. It came from deep space, likely ejected from another star system millions or even billions of years ago. As it neared the inner solar system, telescopes across Earth and in orbit began observing it in every wavelength: visible light, infrared, ultraviolet, and radio. Radio telescopes are our ears to the cosmos. They can detect the faint hum of molecules, the spin of electrons, and the signatures of magnetic fields, the invisible forces that shape the universe. At first, 3I/Atlas seemed quiet, but as it drew closer to the sun, instruments at the Green Bank Telescope in ALMA began to pick up a faint, repeating signal. A structured pulse, a whisper across millions of kilometers. No interstellar object had ever done that before. The data was clear: a narrowband radio emission centered around frequencies associated with certain organic molecules. At first, researchers thought it might be a natural process, radiation interacting with gas and dust from the comet's tail. But the signal didn't match known patterns of outgassing or solar wind interference. It repeated in intervals too regular to be random noise. Was it chemical, magnetic, or something else entirely? The world took notice. For decades, scientists have searched the skies for technosignatures, signs of alien technology, faint radio messages, or artificial modulations hidden in cosmic noise. And now, the first radio signal ever detected from an object born outside our solar system was defying easy explanation. Theories spread like wildfire. Some said it was a natural plasma resonance, a kind of electromagnetic singing caused by charged particles. Others wondered if 3I/Atlas might not be entirely natural at all. Just 3 years earlier, the first interstellar visitor, Oumuamua, had sparked similar questions. It moved too fast, tumbled oddly, and accelerated without a visible tail. Some physicists, including Harvard's Avi Loeb, suggested it might have been an artificial probe, perhaps a fragment of alien technology. Most scientists disagreed, pointing to natural explanations. But now, with 3I/Atlas producing an unexplained radio signal, old debates reignited. Was this a coincidence? Or were these objects, these wanderers between stars, more than just cosmic debris? The truth, as always, lay buried in data. Every atom in the universe has a voice, a frequency at which it sings. Hydrogen hums, carbon monoxide whistles, water vapor murmurs in microwaves. When astronomers studied the radio emissions from 3I/Atlas, they found traces of hydroxyl, cyanide, and formaldehyde, molecules associated with the building blocks of life. But embedded within that molecular symphony was the mysterious narrowband signal. It didn't drift. It didn't fade like natural emissions usually do. It was stable, persistent, almost deliberate. Still, nature can surprise us. Lightning storms on Saturn emit radio waves that mimic artificial pulses. Comets in our own system sometimes produce coherent emissions as sunlight ionizes their gases. But for 3I/Atlas, one thing was certain. The signal was unlike anything we'd ever seen from a comet before, interstellar or otherwise. For months, observatories around the world coordinated follow-up observations. SETI researchers joined in, scanning for any sign of encoded information, patterns that might suggest intelligence. None were found. No hidden data, no modulation carrying messages across the stars. Instead, the signals seemed to align with bursts of activity as the comet's nucleus broke apart, fragments scattering like cosmic embers. Perhaps the signal wasn't a transmission, but a resonance, caused by solar radiation interacting with charged dust in the comet's ionized halo. It was natural, but no less extraordinary. Because if interstellar comets can generate radio signals, it means they carry magnetic fields, plasma interactions, and complex chemistry from other star systems. They are living fossils of alien worlds, not in biology, but in composition. Each one carries the chemical fingerprint of its home system, written in light, sound, and radiation. To scientists, 3I/Atlas is more than a comet. It's a time capsule. A frozen messenger that has drifted for eons between the stars, carrying the materials that once built planets and maybe, somewhere, life itself. Its radio emissions are like an echo from a cosmic nursery, a snapshot of the conditions in a distant solar system long ago. By studying them, we can learn not only how our own system formed, but how others might differ, how chemistry evolves across the galaxy. Each interstellar object that enters our solar system is a sample of another sun's creation. And every signal it emits, natural or not, is a whisper from the greater universe, a reminder that we are not isolated, but part of a vast, shared story. Astronomers are already preparing for the next encounter. With new survey telescopes like Vera-C, Rubin Observatory, we may soon detect interstellar visitors every few years, or even every few months. Next time, we'll be ready. Instruments will track not only light and motion, but every wavelength, radio, X-ray, infrared, searching for clues. Some missions even propose interceptor spacecraft, designed to launch on short notice and fly alongside these visitors, sampling their dust and plasma directly. If we can study one up close, measure its fields, its chemistry, its signals, we might finally understand the origins of these galactic wanderers, and perhaps find hints of something more. 9. A message in the noise. Narrator. For now, the radio signal from 3I/Atlas remains a mystery, neither artificial nor fully explained. It's a reminder that even in the age of technology and precision, the universe still holds secrets that defy easy answers. Maybe it was plasma, maybe chemistry, or maybe, just maybe, it was a faint echo of something older, a message written not in language, but in physics. Every signal we detect from the cosmos tells a story. Some are from pulsars, stars, or black holes. But a few, just a few, seem to come from places we don't yet understand. And that's what keeps us listening. As 3I/Atlas drifted away, its radio signal faded, vanishing into the static of the cosmos. It returned to the deep, endless night between stars, its story unfinished, its secrets intact. But its passing changed us. It proved that interstellar visitors aren't silent. They speak, if only in whispers, through the language of radio waves and light. And as we listen to the universe with ever greater precision, perhaps one day another signal will come, clearer, stronger, undeniable. A signal not from a comet, but from intelligence. Until then, we wait. We build better ears to hear the cosmos, because every whisper from the dark might be a message, and every visitor from beyond might carry a story of where we came from and where we're going next.